going into a bigger and wider math world today. This notation that you're going to learn is used in all the upper levels of math. It's used as a foundation for describing all kinds of different things in calculus and beyond. Sigma notation, sigma, this is the Greek letter sigma. It's like an E, but kind of stretched out in the middle. And what it is it's a way of showing a sum of terms. So we're going to start with I equal 1, and we're going to go to n. That means that we look at u of I, you go u1, and then it does two things. It ratchets up things by 1, and it adds them up. The beauty of this is that you never have to do, what's your least favorite thing in math? Least favorite. Complex, you're close. We'll get to complex numbers this year, but how do you like fractions? You like them? You like them? Okay. Most people don't. You'll love sigma notation if you don't like fractions, because there are no fractions. Well, you can make fractions, but these will never be fractions. These are all integers, and they go up by 1 every time. So, for example, if you took this sum, I goes from 1 to 6. So the first thing I is going to be equal to will be 1. So if I is 1, 2 plus 3 is 5. Okay? Then we're going to add it to this ratcheting up to 2. So now you're going to go 2 times 2 is 4 plus 3 is 4 plus 3 is 7. Okay? Then you're going to ratchet it up one more to 3. 3 times 2 is 6, plus 3 is 9. And when do we stop? Do we just keep going forever? 4 times 2 is 8, plus 3 is 11. And then you're going to, next, put in a 5. 5 times 2 is 10, plus 3 is 13. And then we're going to put in a 6 here. 6 times 2 is 12, plus 3 is 15. Now, why do we stop at 6? Because that's what it's saying. This is your stop value. You increase by 1, you add the terms, and you start and stop. At the bottom is the start, the top is the stop. This is the start. Okay? So what this thing is saying is that all of this can be added together, 20, 40, this will all be 60. So this is really 60. And that's sigma notation. Sigma notation is a way of showing sums. And you can see a little more details to it, but there's your start at the bottom, your end at the top. You add them up, you increase by 1 each time. No problem. 2 rules. You add the terms and you increment I by plus 1. Every time, no fractional increases. All right, so there's some properties. The properties look like this. If you had a k times this, you could say, all right, put in a 1 for I, and so you get 2. Put in a 2 for I, you get 4. Put in a 3 for I, which will stop, and get 6. This is equal to 12. Is that the same as going I equal to 1 to 3 of I, which is 1 plus 2 plus 3, 6. What are you doing to this to turn it into that? 6 times what is 12? 2. So this is the same as pulling that out in front, kind of like what we did with logs, sort of. It's k times the sigma I goes from 1 to n of u of I. And then this just says you can split these up into 2. And you can, and then probably the most helpful one is this one here. Let's say I had the sum as I goes from 1 to 3 of 22. Well, there's no I here, so this will be 22 plus, now I'll put a 2 in, 22 plus, put a 3 in, 22. This is just going to be 22 times 3, which is 66. So this is just k times n. And that kind of makes sense if you think about it. Here are those properties listed in more formal fashion. Okay, so far we have a number of formulas. And I think what we'll do is we'll just go right to the practices here. Let's just practice these things a little bit. See what you can do with these 5. I'm just going to do a quick go over the first 2. You have 3 halves to the 1, so just write 3 halves, plus, now you change the 1 to a 2. And so now it's going to be 3 halves squared. And then it's going to be 3 halves cubed, and then it'll be 3 halves. And these are, the whole thing is cubed, fourth. And when do we stop? 3 halves to the what? 5. Okay. Do the same thing here. Put in a 1. 5 minus 2 is going to be, 5 minus 2 is 3. Then you're going to put in a 2. This changes to a 2. Now it's 10 minus 2 is 8. And then you're going to have 13. This is 1, 2, 3, 4, and 5. N equal to 1, 2, 3, 4, and we stopped at 5. I don't care what the sum is. How many got those listed out? You're good with that? Now the difference between this and yesterday, is we would just list 3, 8, 13, 18, and 23. But now, when you put the sigma, that means you add them all up. So this is called a series. Okay. All right, so then that's the sum. Good, looks like we're doing okay. Let's do work ahead on these here. So it says 1, 4, 7, and so on. You're going to write a sigma, start at n equal to 1, and we're going to go to, ooh, how many will this be? I don't know. But we could figure it out because what's common here? Difference, right? So we know that the last term is 295. We know the first term is 1. We don't know what n is, but we know the common difference is adding 3 each time. So 1 plus n minus 1 times 3. So if you subtracted 1, you're going to get 294. And you get n minus 1 times 3. Divide it by 3. And you're going to get, oh, I can do this, 98. N minus 1. So then n is going to be 99. So once we know that it's 99 terms, you go 1 to 99, and then you just say, all right, the sum looks like this. What's our difference every time? What's the difference? 3. So we'll write 3n. Boom. Just write that right away. If it's a common difference, write 3 times n. Then if you put a 1 in, you get 3. What do I have to do to get 1 here for a sum? 3n minus 2. Done. Now, are there other ways to do it? Yeah, there's an infinite number of ways. You could start at any number you want here and go 3n plus or minus. But that's the answer. I'm going to write it nice and clear here. N equal to 1 to 99. And this is going to be 3n minus 2 for a formula. This is Sigma notation where we made those up. What do you think? That's pretty good. All right, this one, 8, 2, 1/2, 1/8. We're going to do sigma n equals 1, 2, 3, 4, 5, 6. Now this one, the formula is, what are we doing each time here? My 1/4, okay? Now, we're not going to do 1/4 times n this time. What we're going to do for geometric is we're going to do 1/4 to the n. So one more time. If you're adding the same, you're going to take that difference times n. If you're multiplying by the same, you're going to take that to the n. Okay? So if I put a 1 in here, this is equal to 1/4 to the 1, which is 1/4. Now, what do I multiply that by to get 8? 16 will get me 4. You're close. 32 times 32. Done. 1/4 to the n times 32. So this sigma notation might look like this. N equal to 1 to 6, because there's 6 terms added together. You went 32 times 1/4 to the n. Yep. Do you like doing things the fancy way? No? Don't do it. I'm going to just show you the fancy way. 32 is the same as 2 to the 5th power. What is 1/4? That's 2 to the what power? Negative 2. And then if this is to the n, this is to the n. So you have 2 to the 5th times 2 to the negative 2n. If you want to be fancy pants, everybody does, it's going to be 2 to the 5 minus 2n. This is great. This is good. You can be good, or you can be great. You choose. They're both fine. All right. Give this one a try. 25. I'm not going to say anything online, folks. This is it. We looked at sigma notation. Sigma notation is when you start at k or n or I equal to something. Might start at 1, and you go to a certain term. This is my start. This is my end. And then once you have that, you need a formula in here. Formula will have k in it. If you had 2k plus something, like 3, that's going to be arithmetic. 2 times the difference. If you have 2 to the k, 2 to the k times 3, that's going to be geometric because 2 is your ratio. And that's sigma notation. The purpose is to make a list into a nice, tidy notation.